All right, welcome back. Okay, so now we're going to introduce what we call elementary row operations. Okay, so if you remember from previous discussions when we talked about solving systems of linear equations, we talked about what things can we do to a system of equations that won't change the solution set of the original system, right? So what are those three things? So we can interchange two equations, right? So we can swap out, we can change. So if we have three equations with three unknowns, for example, if we have three equations, we can change the order of the equations and that doesn't have any effect on the solution set for the system, right? So we can interchange two equations. We can also multiply an equation by a non-zero constant because it still represents the same line, right? So we can or plane if it's an equation in three variables. But the point is we can multiply the equation by a non-zero constant and it's not going to change the solution set to the equation or the system. Okay, and then finally we can add a non-zero multiple of one equation to another equation, and that does not affect the solution set. So when we're taking these transformations, right, these are what we call transformations of a system of equations, this also translates into our elementary row operations when we're looking at the matrices, right? The augmented matrix, okay? So what are the elementary row operations? So the elementary row operations, the elementary row operation that corresponds to 1 is going to be that we can swap rows of a matrix, right? So we can swap rows, exchange rows, right? Exchange rows of a matrix, right? So that is one of our elementary row operations. The other elementary row operation that corresponds to number 2 here, this is that we could take a multiple, we can multiply a row by a non-zero constant, right? So we can multiply a row by a non-zero constant. Okay, so this is an elementary row operation here. So this here is also an elementary row operation here. And finally, the elementary row operation that corresponds to number 3 here is that we can take a multiple of one row and add it to another row, right? So we could take a multiple. Now, again, we're assuming non-zero constants, right? So we could take a non-zero multiple of one row and add it to another row. And so this would be the third elementary row operation. So there are 3 elementary row operations that we can do on augmented matrices that correspond to the 3 transformations that we can do to an equation in a system of equations. Okay, so again, so it's basically analogous to what we've been doing already now, but these are what we're going to call elementary row operations because we're dealing with matrices.